Good afternoon, teacher. And together with my team, we developed the work entitled Application of Game Theory in the Allocation of Resources and Cooperation Strategies in Competitive Projects, which will be explaining by the person speaking to you, Haider Villalba. We continue with summary, and this study analyzes how game theory, specifically the prisoner dilemma, can be applied to the distribution of limited resources in engineering projects, where several companies complete videoing simulation in Python. And continue with general objective. The objective is to provide a practical and theoretical vision that promotes the implementation of the method in resource management and in a hypothetical case. In continuous with research question, how can one theory through the prisoner dilemma guide optimal resources allocation and promote cooperation in competitive projects in an engineering context? And continues in methodology. One, hypothetical problems. Two fears, A and B, are competing in the market for a limited resources. Both fear moves are simultaneous decide where to cooperation, B submitting a joint bid, or B submitting individual bids. Problem question. What is the probability that both fears will have the best possibility outcome? 3 points each if the pi this dilemma for 1000 iteration, and the variables and obtaining the initial probabilities for each component to cooperation are those shown in the following table. And simulation in Python. A simulator was created in Python to model the prisoner dilemma repeated and 1000 iteration. Initial odds. At the start of each simulation, each fear is assigned a 50% cooperation probability. We continued with results. For the simulator, the Python programming language was used in the Spider interactive develop environment, which calculates the proportion of interaction in which both players shows to cooperation and one individual. After the overall result, the cumulative result of the simulation showed a 50% cooperation rate between both components in the following type. This suggests that while the temptation to greatly exceeds the possibility of achieving an optimal outcome through comparison is quality significant. We continue on is conclusion. Conclusion is game theory offers a robust framework for understanding conflicts and promoting cooperation in engineering context simulation. Show that cooperation can lead to better conjunctive outcomes compared to competitive approaching that can drastically alter outcomes. This study highlights the need to implement cooperation strategies to optimize limited resources and improve decision making. And finally, we can see the bibliographic reference which served and support for the development of the work. Thank you.